We're going to be working on graphs of the sine and cosine functions, including graphing sine and cosine functions using transformations. First off, for the sine function, we defined it in the unit circle as being the y-coordinate on the unit circle for a given angle x. And so if we're thinking about how, as we move our way around the circle, starting at 0 radians, at which point in the unit circle the y value would be 0. From 0 radians to pi over 2 radians, or 90 degrees, where the y value is 1. Then from 90 degrees to 180, or from pi over 2 to pi, where the y value is 0. Then down to 3 pi over 2, where the y value is negative 1. Then back to 2 pi, where the y value is 0. And so we have a bunch of properties that result from this definition of the sine function. First off, for any angle, there is always going to be a y value on the unit circle, which means the domain is all real numbers. Since the y values are between -1 and 1, then that's the range of our function, the sine function. And of course, we know, based on our point, that we have the x-intercept and y-intercept 0, 0. That's our very first point that we have on the graph. And we also know that the x-intercepts happen wherever the unit circle is crossing the x-axis. In other words, wherever the y value is 0, which is at 0 and at pi radians and 2 pi and 3 pi and so on. And of course, we've got the older properties that we already knew from the previous sections, that sine is an odd function and it has a period of 2 pi. And here's the graph of our sine function. Notice that we've got on our graph the 5 key points that we pass through 0, 0. At pi over 2, we pass through a y value of 1. Then back to pi at y value of 0, at 3 pi over 2, -1, and at 2 pi, 0. And the second half of the graph, the left side, that's just, of course, another cycle of the sine function, so it has exactly the same shape. Remember, sine is a periodic function, and every 2 pi it repeats itself. Now for the cosine function, we've defined that as being the x-coordinate on the unit circle. And if we're thinking about the x-coordinate on the unit circle, when we started at 0 radians, the x value on the unit circle is 1. As we make our way up to pi over 2, the x value is 0. Then when we make our way to pi, it's -1 for the x value. Then the x value is 0. Then the x value is back to 1 again once we make our way to 2 pi. And we've got similar properties for the cosine function as we did for the sine function. In fact, it has the same range. The y values are between -1 and 1, and so are the x values. They're between -1 and 1. So sine has a range from -1 to 1, and so does cosine. We also know that the y-intercept for this graph, we have the point 0, 1 on it. That was one of our 5 key points. So our y-intercept for the graph is 0, 1. And we know that when we are at 90 degrees or at 270 or any angle that's coterminal to that, that's where we'll have our x-intercepts. So at pi over 2 plus or minus, 3 pi over 2 plus or minus, 5 pi over 2 plus or minus, and so on. And here's our graph of the cosine function. Notice the two basic shapes that we have so far, that for the sine graph, we begin at the origin, and then we make our way up, then back down to the x-axis, then down and back up. For the cosine function, we don't begin at the origin. We begin at the maximum value of 1. That's where our very first key point is. And then we make our way down and back up again. We define for sine and cosine functions, since they both have an absolute maximum value and an absolute minimum value, we define the amplitude of the sine function or the cosine function as being the distance from the center of the graph to the top or the center of the graph to the bottom. If we're looking at the cosine graph, for example, if we're looking at from the middle of the graph to the very top, it's a distance of 1 unit. So for the cosine function, the amplitude is 1. Similarly, for the sine function, the amplitude would be 1 as well. Now, if we have a number in front of our sine function or in front of our cosine function, then we know that this carries out a vertical stretch of our graph. So for the regular sine and cosine function, sine x, cosine of x, we have that the amplitude is 1, and of course if we have a vertical stretch by a factor of a, we're multiplying all of our y values by a. That means now we'll have an amplitude of a. We have, of course, absolute values on this for our calculation of amplitude, and that's because, of course, the number in front of the sine function or cosine function could be negative, meaning not only a vertical stretch, but a vertical flip. But amplitude doesn't take into account whether the graph is flipped or not, because, of course, if you flip the graph, it'll still have the same amplitude. The distance from the middle to the top will still be the same distance as it was before you flipped it. For the number that's in front of the x, the b that we have here, we know that that represents a horizontal compression by a factor of b. So that means that we will be compressing our graph in by a factor of b, or in other words, dividing all of our x coordinates by b. And so that means that normally if the period for the sine function or cosine function is 2 pi, then for cosine bx or sine bx, the period would be 2 pi divided by b. Now, notice again, I've got absolute values on that b, and that's because if b were negative, it would also mean a horizontal flip, reflection in the y-axis, along with that horizontal compression. And the period is always going to be a positive number. It's a measurement of length. So period would be then 2 pi divided by b. So we now have a couple of examples to work through. For the first one, we have y equals -3 sine of x over 7, and we'd like to know the period and the amplitude for that function. And if we're first thinking about the amplitude should be the absolute value of -3, which is just 3. And that's, of course, because we're taking our sine function and we're stretching it by a factor of 3 and, of course, reflecting it in the x-axis. So now the amplitude would be 3. And for the period, notice that we have sine of x over 7, which you could think of as being 1/7 times x. So if you're dividing every x coordinate by 1/7, that's the same thing as multiplying every x coordinate by 7. This will be a graph 7 times stretched out wider than the original sine function. The original period is 2 pi, and of course we're dividing that by 1/7, so that our period for this function would actually be 14 pi, that every 14 pi, that's how long it would take to make one full cycle. And after 14 pi, this sine function repeats itself again. For the second problem, y equals half cos -4x. We have for the amplitude should be just 1/2, because of course absolute value of a half, or just 1/2 for that amplitude. So this would be a cosine graph that's half as tall as the original one, and it's cosine of -4x, so that means that we are going to compress our graph by a factor of 4. It'll be 4 times skinnier, 4 times narrower than a regular cosine function. The period here would be then 2 pi divided by our absolute value of -4, or same thing as 2 pi divided by 4, or pi over 2. So in other words, for this, the amplitude would be 90 degrees. Every 90 degrees, this cosine function will repeat itself. So we'd like to come up with an equation for this function. And if I'm looking at this, the basic shape of this function is a cosine graph. If we flash back to our basic shapes, remember that the cosine function doesn't begin at the origin, whereas the sine function does begin at the origin. So for this graph, I'm looking at it, it doesn't begin at the origin, so I'm not thinking of this as being a sine graph. Instead, it starts at 3 and goes down to as small as a y value of -3. So if I were to describe this, I would say that this graph has an amplitude of 3. Now, the other thing to notice here is, if we're thinking about it, it's a cosine graph. Is it multiplied by 3 or is it multiplied by -3? Remember that for the original cosine graph, we start off at the positive side for y values and then make our way down to the negative side for y values. So this graph that we have hasn't been reflected in the x-axis. It is just a graph for the cosine function that has been stretched but not flipped. So this will be a cosine function that's multiplied by 3. The next thing for us to know here is that the period is a length of pi, because remember, for the cosine function, as it makes its way in one full cycle starting from y value of 1 down to 0, down to -1, back to 0, back to 1, that's one full cycle for the cosine graph. And here on my graph, that's completing in a period of pi units. Now, you know, of course, that the period is 2 pi divided by the absolute value of b. And so if our period is supposed to be equal to pi, we can make the conclusion here that absolute value of b must be 2. In other words, this is a cosine graph that's been stretched or compressed in horizontally by a factor of 2. It's 2 times skinnier than a regular cosine graph. Now, of course, is b positive 2 or is b negative 2? Well, the nice thing about this is, because it's a cosine graph, cosine functions are even. They're symmetric around the y-axis, which means if you did reflect it in the y-axis, it would look exactly the same. So b could be positive 2. You could say we've compressed it by a factor of 2. You could also say b is negative 2. You've compressed it by a factor of 2, and you flipped it in the y-axis, because of course, flipping something in the y-axis, if it's an even function, it won't look any different. So I'm going to go with the positive version here and say that I'm going to use b being 2. So that means the equation that I would give would be that y is 3 times cos of 2x. Now, I kind of alluded to this in the last problem, where you can use the symmetry of a trig function to do some simplification. So for example, here I say that if I were graphing y equals 5 cos -3x, I could just drop off the negative. And why am I allowed to do that? Why can I get away with that? Well, the answer is cosine is even. And because cosine is even, cos of -x is the same thing as cos of x. So cos of -3x is the same thing as cos of 3x. That essentially we can just get rid of that negative because the cosine function is symmetric around the y-axis. Similarly here, if you're looking at -2 sine -4x, and 2 sine 4x, why do they have the same graph? And the answer to that, of course, is sine is odd. And of course, since sine is odd, that means that sine of -x is negative sine of x. So if you're thinking about the -2 sine of -4x, essentially we can take that negative outside, and that makes it now +2 sine of +4x. So I've said before, for these graphs, the sine function and the cosine function, for one cycle there are 5 key points, and we're going to use those 5 key points, the ones where we're at the maximum value, at the minimum value, and also the x-intercepts, that together those are our 5 key points. So the idea here is, since we know the key points for the sine graph, and we know how to carry out the vertical stretch that we have in front or the horizontal compression that we have in front, by multiplying the y values by a, by dividing the x values by b. Essentially, we can do a graph of a transformed sine function or a transformed cosine function all in one step. So our plan here first is I would rewrite the function. If b was negative, I would use the symmetry of my graph to rewrite it with b being positive. That's why I say here this method to graph y equals a sine bx or y equals a cos bx, where b is positive. And the reason why we can always imagine b being positive is because we know the symmetry of sine and the symmetry of cos. So if we want to rewrite it with a positive b, we know how to do that. So once we've done that, we find our period, and the period is 2 pi divided by b. I don't need absolute values, of course, because I've rewritten it where b is now positive. Once I've done that, I'm going to take my interval and chop it into 4 equal-sized pieces. Because, of course, if you're thinking back to the basic cosine function that we saw, or the basic sine function, as you move from one key point to another, from the maximum value to the x-intercept, that's the same distance as from the x-intercept to the minimum value, and that's the same distance horizontally from that minimum value to that next x-intercept, that for this graph for cosine of x, where the period is 2 pi, every 90 degrees is one chunk. It's one of the 4 subintervals. So, going back, once we've taken our period, we're going to divide our big interval, the full period of 2 pi over b, into 4 subintervals. So for example, I have here, if you've decided that your period is pi, then that means you will be cutting pi into 4 equal-sized chunks, or in other words, pi times a quarter. So the length of each subinterval will be pi times a quarter, so you'll start out going from 0, then you'll go up to pi times a quarter, or pi over 4. Then from pi over 4 to 2 pi over 4. And 2 pi over 4, of course, is the same thing as pi over 2. Then from pi over 2, which is 2 pi over 4, to 3 pi over 4. Notice that the endpoints of these subintervals each time are going up by pi over 4. Pi over 4, 2 pi over 4, which is the same thing as pi over 2, 3 pi over 4, 4 pi over 4, which is the same thing as pi. So once we've taken the period of our graph and chopped it into 4 pieces, we can easily find the tick marks that we'll be using along the x-axis. And then we know for the sine graph, for example, it starts at the x-axis, goes to the maximum, back to the x-axis, down to the minimum, back to the x-axis. So if you did a vertical stretch by a factor of a, then you'd be going, instead of from 0 to 1, you'd be going from 0 to a. And of course, if a were negative, then instead of going from 0 to an a that's above the x-axis, you'd be going from 0 to a that's below the x-axis. Then back to 0, negative a would be positive, and back to 0. So that's our idea here, is that you take our period, chop it into 4 pieces, we'll look at the amplitude and use that to figure out the 5 key points. Once we've plotted our 5 key points, connect the dots to make a cycle. And then if you need to draw more than one period, then that's all you need to do then, is just repeat your graph a second time. And we're going to do a couple of examples of this. So we'd like to sketch 2 cycles of the graph of y equals 2 sine 5x, negative 5x. So first off, I'll use the fact that sine is odd. And so that means that instead of sine of negative 5x, remember sine of negative 5x is the same thing as negative sine of 5x. So in other words, that negative can just come on outside. We have negative 2 times sine of 5x. Okay, so I'm going to just zoom in a little bit to give me some more room to write here. Now that we have that ready, we know that we're working with the function y equals negative 2 sine 5x. We can now talk about the period, and the period should be 2 pi divided by 5. So in other words, the entire period from beginning to end will be 2 pi over 5. So that's going to be almost, I'm not even going to try to do the calculations in my head as to what that is in degrees. But we've compressed things in by a factor of 5. So instead of 360 degrees, it's 360 divided by 5. So the length of our subintervals, we find that by taking that period and slicing it into 4 equal-sized pieces. So to slice it into 4 equal-sized pieces, that means we would be taking 2 pi over 5 and multiplying it by a quarter. And of course, the 2 and the 4 cancel to leave me just with pi over 10 once I've simplified it. So that means that my length of each subinterval is pi over 10, but that also means that the endpoints of each subinterval will be pi over 10 more than the previous. So for example, if we're thinking about our little tick marks that we'll be putting along our x-axis, it'll be starting with 0, then we'll go up by pi over 10. We'll go up by pi over 10 again, or in other words, 2 pi over 10, which is the same thing as pi over 5. We would then go up by pi over 10 again. That would be 3 pi over 10. Then at 4 pi over 10, and 4 pi over 10 is same thing as 2 pi over 5. So each time just going up by pi over 10. If you're having trouble imagining going up by pi over 10, you can just imagine going up by a tenth, from 0 to 1/10 to 2/10 to 3/10 to 4/10. And of course, each time it really should be that instead of 1/10, it's pi tenths. Instead of 2/10, it's 2 pi tenths. But that's an easy way to sort of imagine doing our calculations. So what I would do at this point, now that we've figured out our tick marks, I'll set up my x and y axis and put in my tick marks. I also know, because of my sine function, that the number in front is -2. In other words, this is a sine function that's been stretched vertically by a factor of 2 and also flipped in the x-axis. That this means that instead of having the top value being 1 and the smallest value being -1 for y values, the largest y value will be +2 and the smallest y value will be -2. So I know the tick marks for the x-axis, I know the tick marks for the y-axis, and away we go. Let's start plotting. So remember that we are graphing, even though I have it labeled here as y equals 2 sine -5x, that we have imagined it as -2 sine 5x for graphing purposes. So remember that the usual points that we plot, the usual key points for the sine graph would be 0, then a, then 0, then -a, then 0, where a is whatever the number is that we have in front of our sine function. Here, the number in front of our sine function is -2, which means our y values will be going from 0 to a, which is -2, back to 0, back to -a, which is +2, back to 0. And notice here, for my tick marks on the positive ones, pi over 10, pi over 5, 3 pi over 10, 2 pi over 5, once I have the positive side of the x-axis, the negative side of the x-axis is just a mirror image. So now I can connect the dots and try my best to make a smooth-looking sine function. That was reasonably good for working with a stylus. And now, of course, I know that my graph for the sine function is just going to repeat that shape, which means we will be going up to a y value of 2, then down to a y value of 0, then down to a y value of -2, then back to a y value of 0. This is not the smoothest looking sine graph I've ever created in my life, but good enough. good enough for now. Of course, don't forget, and I'm going to have to skip this just because the stylus doesn't let me write as finely as I'd like. We should be labeling these points because they are part of our important points that we're plotting. Anytime we're plotting a point, we should label its coordinates. We don't have to label the x-axis coordinates for the x-intercepts because, of course, it's passing through at the tick marks. We already can read off directly from the graph negative 2 pi over 5, 0, negative pi over 5, 0, 0, 0, pi over 5, 0, and 2 pi over 5, 0. But we really should label the maximum and the minimum values on our graph because they are our key points. Okay, one more. Sketching two cycles of the graph y equals negative 3 cos of negative x over 2. Now, for this one, we just remind ourselves, of course, that cosine is even. Cos of negative x is the same thing as cos of positive x. So we can say that actually we will be graphing negative 3 cos of x over 2, which you might find it easier to think of it instead of x over 2, thinking of it as half x. And that's, of course, when we're calculating our period. The period then should be 2 pi divided by a half, which is the same thing as 2 pi multiplied by 2, or 4 pi. So our graph will be 2 times wider than a regular cosine graph. And for the lengths of the subinterval, that would be four pi times a quarter. So 4 pi multiplied by a quarter, because we have 4 subintervals, so we're taking our period and chopping it into 4 equal-sized pieces, and that would be then pi. So then our tick marks along the x-axis would be 0, and then pi, and then 2 pi, and then 3 pi, and then 4 pi, each time going up by pi. So that's our beginning work, our analysis that we're doing. So we now have, starting from dealing with the symmetry of our graph first, rewriting it as cosine half x rather than negative half x, using this to find our period of 4 pi, chopping our period into 4 equal-sized pieces to find out how long each subinterval is. Each subinterval is pi units. And then from that, we can find our tick marks, always starting with 0 and each time going up by pi. So now we are ready to go. We have our x-axis created. We'll know for our y-axis that the y values will be as large as positive 3 and as small as negative 3. And that's, of course, because of the negative 3 in front of the cos of half x. And the only last thing for us to remember here is that for our key points for the cosine function starts at a, down to 0, down to negative a, back to 0, back to a, where a is whatever the number is in front of our cosine function. And of course, for our cosine function, the number in front was negative 3. So we will start at a, which is negative 3. We'll go to the x-axis, then up to negative a, which is, of course, positive 3, back to the x-axis, and down to a again. And we will try to make this as smooth as possible. Not so good. I am not going to be teaching any art classes anytime soon. Okay, but of course, now we know that there we go, makes that look less garbage. So now we know that for the next part of the graph, the other cycle, it's just going to repeat the same shape. From the y-intercept of negative 3, we'll go up to 0, then up to 3, then down to 0, then down to negative 3. And same thing that I said before, don't forget we really should be labeling these. not that one, these points. Any point that isn't one of the key points on the x-axis or y-axis. So those points that I have where we have the points -4, -3, the point -2, +3, the point +2 pi, +3, the point 4 pi, -3. Those 4 points I should be labeling on my graph. Just for the problem of dealing with this stylus, I'm skipping that for now, but if I were working on the chalkboard, that is what I would be doing. And that's, of course, what I do want to see in your work as well. Also, don't forget to label the curve itself. And notice here I've got my graph labeled just as I had the previous graph labeled with its equation. Always a good thing to do. So one more transformation that we can work in, of course, is a vertical shift. And so if we have an amount added to the end of our sine function or our cosine function, that this is a shift upwards or downwards. If k is positive, shifting it upwards. If k is negative, shifting it downwards. Basically, the idea is the same. First, start by graphing a sine bx or a cos bx. In other words, deal with the vertical stretch and the horizontal compression. Once you know where those key points are, great, good for you. Now you just add k to every y coordinate, because that's exactly what a vertical shift is. Whatever k is, that's the amount that's being added on to the y value. And then, of course, if you need to do 2 cycles, then once you've done 1 cycle, just repeat what you've got. So we have this function, y equals 2 sine negative pi x plus 1, which, if I were going to rewrite this, of course, I would think about the fact that the sine graph is an odd function, which means sine of negative x is the same thing as negative sine of x. So in other words, I will be graphing -2 sine of pi x. And that will be equivalent to 2 sine negative pi x plus 1. There we go. Plus 1. Good. So as far as the period goes, for the period, we are taking 2 pi and dividing it by pi. So in other words, the period is 2. And so for length of subintervals, that would be taking that period of 2 and chopping it into 4 equal-sized pieces, or 2 times a quarter, which is a half. So that means that your tick marks are going to be 0, a half, 1, 3 halves, and 2, each time going up by 1 half. And those, of course, those are our x values. For our y values, if we were just thinking about -2 sine pi x, then of course our y values would be, we start at the origin, we go to a, which is -2, back to the x-axis, now to -a, which is +2, and then back to the x-axis again, y value of 0. So 0, a, 0, -a, 0. And now, of course, we have a vertical shift upwards, by 1. So that means each of our y values I will be adding 1 to. So we'll have, instead of y values of 0, -2, 0, 2, 0, we will have y values 1, -1, 1, 3, 1. So let's plot those. We had y values of 1, -1, 1, 3, and 1. And I will do my best to connect the dots. That turned out fairly okay. And I've got my 5 key points, 4 out of the 5 key points I would need to provide labels, because of course none of those 4 points in red are at tick marks. The one that's the y-intercept, we can just leave that one unlabeled because we can read directly off the y-axis what that value is. And of course I wanted to sketch 2 cycles of this graph, so that means then I'll just need to continue my graph on the other side, which means the y value will be then going up to 3, then back to 1, then back to -1, then back to 1 again. And there we go. And of course, I would want to label those coordinates for those points as well.